Welcome to this presentation on study of photothermal conversion characteristics of metal oxide nanoparticles-based phase change materials. This research was conducted by Ankura Ansali and published in 2025. Today, we will explore the key findings and contributions of this important work. Let's begin by understanding the problem this research addresses. Have you ever wondered how we can store solar energy to use it later, even when the sun is not shining? This is a big challenge because solar energy is not always available when we need it. We need ways to capture and save that energy for later use. One promising solution involves materials called phase change materials or PCMs. These materials can absorb and release large amounts of heat as they change from a solid to a liquid or vice versa. To conduct this research, scientists started with two common PCMs, palmitic acid (PA) and polyethylene glycol (PEG). Then added different metal oxide nanoparticles, specifically aluminum oxide, iron oxide, and titanium oxide, to these PCMs. They varied the amount of nanoparticles added, using 0.5, 2.5, and 5 by weight. The results of the experiments showed that adding metal oxide nanoparticles did affect the properties of the PCMs. For example, the DSC analysis showed that the amount of heat the PCM could store, known as latent heat, changed when nanoparticles were added. In some cases, the latent heat decreased, but in other cases, it remained relatively high. The findings of this study are very encouraging for the development of more efficient solar energy storage systems. The metal oxide nanoparticles enhance the photothermal conversion of the PCMs. These nanoparticles help to absorb the light and turn it into heat faster, thus that their optical properties and how well they disperse within the PCM plays a key role. In conclusion, this study shows that incorporating metal oxide nanoparticles into phase change materials can be an effective way to improve their photothermal conversion and energy storage capabilities. By carefully selecting the type and amount of nanoparticles, it is possible to create composite materials that are more effective at capturing and storing solar energy.